This is Ready Layer 1, Intro to the Model Context Protocol. And quick show of hands, who is being asked to do more AI at work? And who likes this? Yeah, so I think that we'll go into some ways to empower us to do more with it in better ways. And what we're going to cover is, real quick, we're going to do a high-level view of LLMs and AI agents, what the actual model context protocol is, and then do some Android device control with AI. And what I hope you take away from this whole presentation is just to get a lens into what the model context protocol is and offers you, and then enables you to build your own MCP servers so that you can use AI at work in a way that benefits you more. So what is a large language model, or LLM? Basically, it's sequence prediction at a really massive scale. They're trained on broad data, fine-tuned to task-specific patterns, and they have a couple interfaces of chat, code completion, and APIs. And then how do they work? You give it some text. This is a prompt. It tries to predict what comes next one piece at a time. And it doesn't think or know, but it follows patterns, and it's really good at this pattern matching. And if we wanted to do a quick exercise, we'll say that the Android developer invalidates, caches, and restarts, something that we're very familiar with. So some LLMs in action. We want to do something with ADB. So real quick, let me exit this, and I'm going to throw ChatGPT up here, and I'm going to ask it to do something with my Android device. And it's usually pretty good at this. Let's see if I can grab the device. Cool. So it's gonna tell us some things, and that is a little small from that screen. Yeah, so to do this stuff, we'll need to run this shell with this package name with a launch, and some of these aren't correct. So this is stuff that it's not sure about, but there's no way for it to validate itself, and then I have to go back in and do all of this. So what's happening is, I know those won't work, so unfortunately we won't test those out. But I, the human, have given a prompt to the LLM. It's given me a response, which then comes back to me. I get to take the action, and we repeat this ad nauseum, feeling like we're being controlled by the AI instead of the other way around. And this isn't great. It doesn't feel good, and we end up doing most of the grunt work. And we really should have it be the other way around, where we get to ask the LLM to do something for us, and then it does that thing and then returns back to us the result of doing that thing. So that enters AI agents. What is an AI agent? It's a system that uses a language model to do these sorts of autonomous tasks. It's a language model. It has a bunch of tools it can call, and then a planner to decide on the sequence of actions to complete that task. This is the agent loop for Goose, which is made by Block and is open source. It starts with this human request, which comes in through a chat. It determines if it wants to call tools, does those tools. While it's updating in the tools, the UI will render what's happening. And then if it needs to complete the task, it will continue through this loop until it realizes or thinks that it has completed the task, which then returns the response. And that was Goose. There's a couple other agents like Claude Desktop, and then most recently, Gemini and Android Studio, as of the Narwhal feature drop, has added an agent mode, which does also support the model context protocol. And the key thing here is AI agents need tools. So this is what gives the LLM a connection to the real world. So it's a form of input and output. And then it needs to describe what's available, when to use, and how to use it, because at the end of the day, we're still dealing with an LLM that can glean context and information from from what we give it to learn how to use the tools. But how do we make these tools? And that's all done through this model context protocol. So all this is a JSON-based protocol. It lets us share this information with LLMs. We get to expose what's possible to the agent. MCP servers can call other servers, so it's a composable architecture. And it enables us to describe the tools themselves, which this is one of the key components, because the more that an LLM knows about what it's trying to do and what it has the ability to do, the better it can do those things. And this is all built on a set of features. These are the primitives of MCP. So something like resources, this is going to be like your documentation to your tooling or your code base or something. Prompts, which are essentially pre-written templates that if the user is asking for something, the agent can then use this template because the MCP server might be able to tune the response. We the developers of this server can tune the response because we know how to prompt better for that specific task. And then tools, this is what actually connects the AI to the real world. And so the servers themselves are very easy to build. They expose these resources, tools, and prompts as primitives, and they can work with local or remote processes. And so to get a quick high-level view of what this architecture looks like, there's an agent on the left-hand side here. There are some calls or some things that we want to accomplish or work with in the middle, and then whether or not that is a local or remote data source. Now, we could go and create these tools as one-offs, but they wouldn't work across agents, they wouldn't work across platforms, but MCP lets us have that unification. So if we implement the weather, the ADB, the calendar, MCP servers, they all conform to this protocol and tell the agent what's possible. It can then learn, and based on what you're asking it to do, go and work with these things in a more effective way. And so let's build one. We want to work with ADB. We tried to do that earlier, and it kind of gave us some responses, but it didn't have the right package name, and it required us to do all this stuff for us. But we'll use the Kotlin SDK, and let's just assume that we have an easy way to call into ADB from Kotlin. It could look something like this, where we have an ADB function that has a command that calls to a process and returns the output of that process. So with that established, we need a way to unify this through MCP. And then, because we're probably going to add a bunch of different ADB tools to this structure, we'll create an interface so that we can define them as specific functions and really tune what we want to gain out of this ADB. And then a real quick piece about server setup. There's a couple of different ways. The Kotlin MCP SDK handles this for you really well. And there's a bunch of really great examples in that repo where you can set up the server. You can use server sent events, which uses an HTTP transport, or you can use standard IO, which is just your standard output to text. Careful if you're doing that. If you print to debug or anything, that also goes to standard IO, so that can end up in your agent and your LM would be reading that. And then we're going to be using the server sent events today through the Ktor plugin, and that setup just looks like this, just some output, and then it calls configure server, which does some stuff. And I'll go through this later once we're in the IDE a little bit better. But it lets you define what your server is capable of, gives you some callbacks so that when you're done with the loop, it can close out. And then it lets you do some things like stand up the actual functionality that you want. So for this, we'll create an ADB manager. We'll have our tools registry and register all those tools to the server. And these are all APIs that the Kotlin SDK gives us. And then we'll add a prompt at the end to tell the server about what this MCP, or tell the client, sorry, the agent, what this MCP server does and all of the tools that it has access to. So let's do that. I'm going to jump to IntelliJ and bring that up here. So this is our main function. This is where we actually are going to go and launch this server. This is very similar, if not the same code that was in that slide. The configure server function does this server setup, where this is the implementation with the options, and then we instantiate our manager, get the tool registry, and then down here we have the prompt. And so looking a bit into this callback of the prompt, we can kind of seed the devices that we currently have connection at the time of the agent's initialization. And then the prompt here is the message of all our devices, the device info, and then all of the available tools. And so if we want to look at how to define these tools, actually real quick, we'll jump into the ADB manager. This is like that interface around what ADB offers. So this is how we are connecting from Kotlin into what ADB allows us. So this, if we look at the structure of this class, we get to see that we have execute a command with a string, and then a bunch of different ways to do things with ADB. So a big one that we'll be showing is this get UI layout. So this is going to call to ADB. There's a bunch of device error handling in here for this case. And it stores some to a file, but where's the actual UI? Yeah, so this UI automator dump, this is going to return a view hierarchy in XML format from ADB to the LLM. And so now we've given a text representation, which LLMs are really, really good at, to our LLM to see what we are seeing on the device. And it can get all sorts of things like accessibility information to like XY coordinates to interface with taps. And tapping on a screen is the other great thing that ADB allows us to do and enables the LLM to start interacting. And so that's a pretty basic command where we have our XY coordinates and then ADB shell input tap. And there's so much that you can do with ADB. It's really a powerhouse. If you haven't explored the Android debug bridge, I really recommend it. It's a lot of fun. And like if you have to authenticate or log in to a developer account or something, you can write a little ADB script to do that for you and not type it every time. But soon we'll just be able to say to the LLM, log me into my account, and that's going to be great. And so all this is this sort of wrapper where we want to execute a command, we call tap on this manager. To tell MCP about this, or to tell the client, the agent about this, we have to wrap this in an MCP tool. Oh, we're gonna have to navigate. So that's gonna happen in this tools registry. This is just a standing class to encapsulate all of these tools into one spot. This is purely for the management of all these various tools at the same time. But we'll look at the tap tool first. And so all we have to do here is we define a tool. I wrapped the actual tool interface into this Android tool piece, so it's a little bit easier to reason about and move and define the descriptions around. But really, at the end of the day, it's kind of the same interface, and this is provided by the Kotlin SDK. It's just a name description and input, and this is where we build that JSON object to tell the agent what we are able to do with this, or what parameters that we need from it. And so in this tool, the tap tool, we give it a name, and then we give it a description. And like I said earlier, these descriptions are really the powerful part of this, because the LLMs, they're really good at text. They're good at gleaning some reason out of what this is supposed to do, and then follow the patterns based on what's expected. And the better description you have, this is how you're going to tune what's possible and how this is going to work with your server. The input schema, so for tapping, we need to know the XY coordinate of where we're going to tap. And then there is a handler to handle the output, which then returns back to us through the agent. And so we try to grab our X, we try to grab our Y, and then any specified devices, if we have any issues, we would just want to validate that, because that's also valid information for the LLM. It's able to iterate on itself and stay in that context loop until it thinks it's completed the task. And then if we make it through all of that validation, at the end, we get to actually call the tap event. And so we do this tap, and we return the result, and we get to tell the LLM that the tap event has been sent to the device. And this is going to show up in the UI. And so this loop that the agents are going to enter is what's going to enable the agent to take control of this device, because it'll be able to grab the view hierarchy, recognize that, and it has this plan based on what we ask it, tap on an element that it knows is there, and then see the view hierarchy again, tap again, and keep going through this step repeatedly. And let's see, I'm going to quick start this server. And then we will jump over to the Goose agent and see this in action. So bear with me 1 second. All right. So let's see, what do we want to do first? We'll say, we have to make sure that we are connected. So I'll refresh this. Go into settings, and through all these servers. I think I set this up already, but yeah, so we have our Android device control. If we look at these settings, we have our name, the type that we want, so we're going to use the server sent events, and then a description here as well. We give it our local endpoint. These could be remote hosted servers as well if you want to do that. Since this is dealing with local processing, we wouldn't really be able to call to our local ADB from the server unless someone wants to try to figure that out. That'd be pretty crazy. And then we don't need any other variable names. So let's enable this. All right. And then we will say, hey, Goose, let's take a photo with the audience. Use my device. So I'm going to make sure it's unlocked. But what we're going to see is it's going to go through and look for devices, and I'm going to try to run down there and be in the photo too. So it's going to list devices, and we can see some output here that it sees some devices. Oh, and it's going. It looks like it tapped. It looks like it tapped, but I'm not sure if it being horizontal is messing with it. It looks like it's trying to tap up here, like in the corner somewhere. Let's see. All right, so another tool that I wrote for this is to take a screenshot, because sometimes you don't get to get all the information from that UI system dump. And but screenshots are expensive, so we'll see what happens. Let's see. We're still in the camera preview. Let me try tapping larger white circle button. Okay, that sounds good. Yeah, I think it's being messed up by the coordinates. So, see, I fought with this all start. We're gonna quick. All right. I'm gonna cancel this one, and this is the best part about non-deterministic live demos. So we'll refresh, like, hey Goose, let's take a photo with the audience. I'll start from nothing again. And let's see what it can do. So I'm going to bump this up a little bit. All right, so I found the device. We're getting the layout, and I think I'm going to run down again. I'm going to make sure everyone can see this too. All right, so it's going to recognize that we're not in the camera app and hopefully launch it. All right, great. All right, we will try something else. Let's do this. Hey Goose, can you text my friend Adam Neely hello from droidcon? All right, so Adam's here in front row, and we should see if he can get this. So part of this, while this is happening, is defining your tools. We'll go through a couple of tips on best ways to do that later and ways to save on your context window, because having a bunch of different tools is pretty expensive. Like, I wish this wasn't going all through screenshots. The coordinates can mess up a little bit. But here, let's see. So part of this is the descriptions just aren't good enough. So let's go to the UI layout. Let's say we want to use this before screenshots to get the UI. And then in the screenshot tool, where's that one? There we go. Did do this, but do not use this first. Use the, I think I called it out earlier. Use the Android UI layout tool. All right, and then we will restart the server. All right, and then we will restart Goose. Right, and then bring this back up. So I know we're hitting some hiccups here, but ultimately you can see the devices being interacted with, which is pretty cool. It's not super deterministic. It's not super well tuned to specific workflows. These are just endpoints wrapped around the Android debug bridge. Typically, when you want to do stuff like this, and I have a couple slides on tips later, but we want to design from workflows downward. And so if we know that we want to handle texting, we could precede what package name we want to open. We could have prompt inputs for Oh, I guess we're swiping all the way home. We could have package names to like know what apps we want to interact with, template prompts if we want to send specific messages, all these different ways that we can tune the responses. This is a very generic setup, but hopefully it can see on screen. All right, it doesn't know where it is. All right, we will let that cook in the background. But in the meantime, yeah, so some of these tips. We want to design the tools from the workflow. So what you're trying to do is the most important thing. If you can have a tool around a specific job, that's great, because the tools, you get to offset what you're asking the LLM to do, and protecting that context window is really important, because if you're out of that, then you basically have to start from a clean slate. If you can combine a bunch of steps into a single high-level tool, same sort of thing. So the prompt-friendly tool design, like the tool names are prompts. We covered this a little bit, where you want to describe things very well and very accurately. We can see that we're dealing with a couple of those issues now. I think it's still just looping. It hasn't done anything. But yeah, better tool descriptions means better tool use. At the end of the day, LLMs are really good at this sort of text processing. Yeah, so context window is really important. You really want to protect that. The longer you can keep a context window active, the more that you can do within a set of work. So something like sending all these screenshots, those are pretty expensive to process. They can really eat it up. We want to use more text-based things, or we want to use more tools that do more work for us outside of the LLM to then come back, so that we can keep iterating and keep working on stuff. And running out of this is costly, not just monetarily, but also because you might have to restart, and you might have to reintroduce context that you've already been through a couple times. And this is why MCPs can help. Lastly, we have a few more resources. The Android developer community is kind of focused around Blue Sky. Highly recommend checking it out. I put out a call to Blue Sky people who are working with Kotlin and MCPs, and there's some pretty cool stuff that is happening in the open source community around it. And I'm going to show those in a second. It doesn't all have to be work related, which is really cool. The servers are pretty easy to stand up. The actual MCP Kotlin SDK has a lot of really great examples that you can just pull server setup out of and get going with and start writing these tools for your own use. If you need an agent, the Goose agent by Block is open source. All you need to do is throw it some LLM to use, and there's a bunch of setup docs as well on this site. And then also at Block, we've developed a bunch of MCP servers that we use internally for things like working with Jira, with Slack, with Google Calendar, and various other internal tools. So these are our best tips. We covered a few of them here. This doc is great to go into those more in depth, and I highly recommend checking it out. And then from Blue Sky, we see this drum MCP. So Hugo Visser, I'm going to see if I can pull this up. Hopefully Wi-Fi holds out. See, he was able to integrate an MCP for this drum beat app to make new drum sounds. And so he's using Goose on the left here with his device on the right running this app, and he's going to ask it to make a new synth sound, and he's going to go through that, and we'll see if this works. Hopefully it's not too loud. All right, so he's asking to create the drum. Skip some loading. So it's returning the parameters that it used. And then we get to actually see, this is the sound that was made. So pretty cool. Totally random use case, but kind of fun. And then tomorrow there is a talk by Jason Pearson. He's doing some cool stuff with Android and MCPs where you can embed the MCP server in the Android app itself. And I recommend going to that talk to learn a bit more about that. And this is really cool because now in a development environment, you'd be able to have your device expose or use these tools to help work with LLMs. And then at stage 2, there's a talk about AI mobile testing where Sam Edwards and Brian Gardner are introducing Trailblaze, which is a natural language AI-driven test framework. So you can tell your LLM what kind of tests you want, and it's going to record the interaction, take screenshots, and generate UI tests for you, which is really cool. And that's it for me. Thank you very much. Oh, whoops. I just realized I was not back on this screen. But there's some QR codes around. This is the Android MCP that you can embed in an app if you want to check out that project. And then also the stage 2 stuff as well. And if there's any Q&A, happy to answer questions. Thanks for coming.